Hello everyone. Today we'll look into activation functions for neural networks. This is the first video of the deep learning series. So let us get started. What is an activation function? In simple terms, the activation function is an equation that is used to convert an input of a node in a neural network to an output. It is like a logical gate in between the input feeding the current neuron to its output going to the next layer. The main objectives of the activation function is to introduce a non-linearity to the neuron and to determine whether to activate a neuron in that layer or not, such that during the model building only the activated neurons are considered. One more use of activation functions is to scale the input. As the output of a activation function will have a range, what it does is it scales the input to that particular range. So it also helps in scaling, but the main function is to introduce non-linearity to the input. Basic features of any activation function. Number one, it must be differentiable. Number two, it should be ideally non-linear, though a linear function can also be an activation function, but as one of the main functions of it is to introduce non-linearity, activation function should preferably be non-linear. There are various activation functions, a few of which are sigmoid, tanh or hyperbolic tangent function, ReLU, rectified linear unit, and its variants, softmax and swish. Let us look into the sigmoid function at first. What is the sigmoid function? It is basically an S-shaped curve, the function of which is f of x is 1 by 1 plus e to the power minus x. It ranges from 0 to 1. What are the advantages of it? It is simple and smooth. It gives clear predictions, can be used in any layer. What are the disadvantages? It is non-zero centric. That is, as the range of the function ranges from 0 to 1, it is non-zero centric. It can give rise to vanishing gradient. That is, the change in predicted values for the large positive numbers is infinitesimally small. And also the calculation is computationally complex for larger networks. A sigmoid curve is basically used for binary classifications. In practicality, a logistic regression is basically a sigmoid curve or a sigmoid function. Let us see what is the value of sigmoid function of 4. It is 0.982. Now let us see the sigmoid of 5. The sigmoid of 5 is 0.993. So we see it is the value of sigmoid increases with the value of x. Now let's see the value of sigmoid of minus 5. It is 0.006. So we see it is an even function. It is neither an even function nor an odd function, as f of x is not equals to f of minus x, or it is not equals to f of minus x either. It is neither an odd nor an even function. Now let's see how can it give rise to vanishing gradient problem. The difference between sigmoid of 14 and 15 is 5.2562 into 10 to the power minus 7. That's a very small value. That is almost equal to 0, almost very close to 0. So it would give rise to vanishing gradient issues. Now tanh. The range of tanh is from between -1 and 1. What are the advantages? It is zero centric, it accommodates large positive and negative values, and it is quicker for the cost function to minimize when we use our tanh function. What are the disadvantages? One being, it gives rise to vanishing gradient problem. The equation for tanh function is 2 by 1 plus e to the power minus 2x minus 1. Now let us see a few values of tanh. So tanh of 4 is 0.999. Tanh of 15 is 0.9999999. That is very close to, and it goes on for a few more significant numbers. That is, it is very close to 1. Now we see the value of tanh of minus 15. That's the same as tanh of 15, but with a minus sign in front of it. So we see it's basically an odd function where f of x is equal to minus of f of minus x. But now let us see if it gives us the vanishing gradient problem or not. The difference between tan h of 14 and tan h of 15 is 1.19571 into 10 to the power minus 12. That is very small, very close to 1, very close to 0. So it is also giving rise to vanishing gradient issues. Now let's look into ReLU. What is ReLU? A ReLU function is a function which gives a value of 0 if the value of x is 0 or less than 0, and gives a value equals to x for any positive number. What are the advantages? It is simple and computationally efficient. It doesn't give rise to vanishing gradient. It's non-linear. But there are a few disadvantages as well. One being it gives rise to dead neurons. That is, for any negative value, the value of the output is equal to 0, and hence it is giving rise to dead neurons. And the second being, it cannot be used as an activation function in the final layer. Though it solves the vanishing gradient problem, it does give rise to zero activation or dead neuron problems. It looks like this, that is 0 for any number, 0 or less than 0, and or for any negative number, and is equals to x for any positive number. The value of ReLU of 10 is 10, as we see. Now let us see the value of ReLU for minus 0.4 and minus 50. As we see, it's both 0, as it will be 0 for any negative number. There are a few variations of ReLU: leaky ReLU, parametric ReLU, and exponential ReLU. Leaky ReLU is nothing but very similar to ReLU, but with the exception being the value for any non-positive numbers would be a constant number and not 0. And for the positive part, it remains the same as a ReLU. It looks like this. There are a few other variants of ReLU which will be included in a notebook, the link to which would be attached in the description box. Now let us jump to softmax. So softmax is basically very similar to a logistic regression problem, but the value of which is different. So the softmax with n equals to 2 is basically a logistic regression. So the formula being for softmax is exponential of x by the summation of exponential of x, where x being one class. So it basically gives us a probability of the occurrence of one class over the other classes. And softmax with n equals to 2 is basically a sigmoid function or sigmoid function. The next is swish. Swish is nothing but x by 1 plus e to the power minus z by b. Or beta. Beta is, if beta is 1, the activation function is called a sigmoid weighted linear unit. This is how a swish function looks like. So swish is basically very similar to a sigmoid function, but it has got a beta, which is basically a scaling factor. It has been released by Google kind of recently in comparison to ReLU, and gives better performance to ReLU on some cases. This is the function, and this is how the graph looks like. Thank you. This is all for today. Hope you liked it. Don't forget to like, share and subscribe. Bye.